meeting so that people, okay, perfect. Who we are Stanford Data and Mapping for Society, STAMS. You go to our website. Basically, we are the data science club at Stanford. We had a huge growth over the past like 2 quarters. We now have over like 100 undergrad students working in data consulting, data visualization, data journalism, etc. So just to like let you know what we do super quick, we have like different areas. For example, Wes is the lead of our transportation sector. We did work for Alameda County to like show how the bus system worked there and like how delays were going. We also worked with Monterey County for collisions on state routes. We are currently working with Contra Costa County, mapping traffic and collisions in their I-680 interstate road. We work with Berkeley and Oakland about residential instability and gentrification, and are working with the California Transportation Commission, trying to help them get funding for transportation-related projects based on our visualizations. We also have Earth. We're working with the Climate Cabinet, which is an NGO, I believe, and the idea is we're giving all the legislators in America, over 7,000 of them, a climate score based on how they voted on previous policy. We are working with Sustainable Stanford to measure waste at the university. And then on education, we're working with the Common App, trying to get some insights and academic research on how equitable schools are. We're also making like trying to prototype new designs for making the Common App more user-friendly. And we're working with transfer students to help match them to guaranteed community colleges, where like basically if you go to this certain college and you get this GPA, you get guaranteed admission to transfer over to another college. So that's about it. Honestly, we are expanding super fast. These are only 3 main sectors that we're working on, but we have a lot of students who are interested in other sectors like medicine, law, business. And yeah, honestly, like we add new projects all the time. So more than happy to work in any of those if those are of the interest of anybody here. We also do workshops. For example, BeginnR is our intro, as Wes said, to everything else the club does. Basically, we teach you how to do graphs that are static and maps in R, and how to start wrangling data and exploring data initially. Then we have something more advanced to do dynamic graphs. So like when you have, let's say, a checkbox and you want to like choose a variable and show that data based on a variable, that's more dynamic. Wes also did an Adobe Illustrator workshop too. We're doing things on pulling live data. For example, we have a vaccine tracker in the world, which we use pulling live data from GitHub every single day. Well, that's at it. We also have like data journalism workshops with a package D3 that the New York Times uses and other like journalism organizations use. We actually had a co-president that worked at the New York Times for like 2 years. And also we're moving more into like data sciencey stuff with statistical regressions, and also like that is more of an area that we're looking into expanding in the future. This is our COVID vaccination tracker. Peru, where I'm from, doing terribly. United States doing much better, and China surprisingly doing well too. Yeah, so that is DAMS. Does anybody have any questions about like how the club works or anything? Just like feel free to speak up or just pop them in the chat. Okay, sounds good. Also, I'm not recording everybody's faces, but I might in a second if I move back to Zoom. So if you guys just want to like turn your camera off in case you don't want to be seen on YouTube, because this is going up to the world. But if you don't want your voice to be there, you can just like type into the chat. That's fine too. Okay, that is down. Basically, moving on to how BeginnR is going to work. So how this works is every Wednesday we have a meeting from 6 to 7:30 p.m. Pacific. And the idea is for like the first 30 minutes we do demos where like we explain new functionality in R. And then we move you guys into breakout rooms, which we like mix up every single week to try to like get to meet new people. There's like 60 or 50, like it varies per day, people that are signing up for synchronous R. So there's a ton of people to meet: upperclassmen, underclassmen, staff, faculty, etc., alumni. And yeah, this lasts for 9 weeks. We're already 2 weeks in. It lasts until June 2nd. And ideally, we have this thing called C1. It stands for Challenge 1. Which is an independent project that we encourage everybody to work on at the end of this workshop. The idea of a C1 basically is choosing something, a topic that you're interested in, choosing a big question that you want to answer, and then finding some cool plots to answer that question. So I'm just going to take this example from Claire Morton from data journalism. Claire was interested in environmentalism, and her question was, in San Francisco, are green spaces equitably distributed? So her first like sub question to answer this was, okay, like what is the distribution of green space in San Francisco? So she made a map of all, I guess, like the boroughs of San Francisco, and like shaded green space, like in a darker green and that sort of stuff. And then she tried to like superpose that and find the correlation between green space and poverty as well as non-white residents. Turns out that there was not a very solid correlation. So then she asked the follow-up question. Okay, so if green space does not correlate to like wealth or like race, how about tree cover? She basically did something similar. She also found that the more residents in poverty, the less tree cover there was, same for race. And then she asked a further question, okay, what about park quality? Like, does it have anything to do with equitability here? And she found that race also has a significant impact on the quality of parks in San Francisco too. So her conclusion was that there is, although there's like a just distribution of like park area, it is not fair in terms of shade and the quality of parks. Honestly, it should not be that big unless like you can put as much as you want into this. We expect like 10 hours if you choose to do it like outside the class. If you don't, that's totally fine, but we do use C1s as like a pipeline for like further involvement in projects in the club. But yeah, honestly, this does not have to win a Nobel Prize. Just like it's taking a topic of your interest, doing something that you find appealing, trying to answer a big question. My only regret was when I did this like 6 months ago, I did not have a big question in mind. I did something on like foreign aid from the US to other countries, and I did not know what I wanted to answer. So I spent like too many hours like finding correlations that I didn't know if like they were going to be like useful. So have a big question, have something planned that you want to like look into if you're interested in doing these. And finally, we're gonna have office hours every week. We sent the when to meet to people in the Slack, and we'll be posting those hours tomorrow. Can I take any questions about like how this works, how BeginnR works, about C1s in the chat, or just speak up?
I guess for the C1, so that should become like something that we're already interested in and have a data set for, or
Yeah.
And where do we find the data for the C1s?
Really good question. We always get like this question of like, does the data set come before the question, or does the question come before the data set? We always say the question comes before the data set. Like find a topic. It doesn't have to be anything that you worked on. It can be totally new that interests you. For example, in my case, I just wanted to do something on foreign aid. So the first thing I Googled was foreign aid US. And literally like the first search result was like government website with all the data. It was easy for me. But in some cases, like you do have to dig deeper into like academic publications or like Stanford databases. But yeah, I'd say like go for the question first, find a data set that you think is comprehensive. Like when I went to download, I realized that like this had data from like 9/11 to today of like all the payments that the US made to other countries. So like it was perfect to answer my question because it was super complete. And like at first glance, I knew that it was going to give me some insight. But yeah, like find a question, find a data set that you kind of like get an idea that you're going to get some information and questions that you want to explore. And then you get to go. Otherwise, like complement it with new data sets or find a new one in that case. But yeah. I think I have a question in the chat. I hope that answers your question though, if that helps. Can we bring our own data set? Yeah, of course. Yeah. Any data set that you want to use is perfect. Great. I love the excitement. Actually, we have so many people with different interests in this session of BeginnR. Yeah, we're very much looking forward to what people come up with. Great.
So,
yeah.
Just as a general question, because looking at all the like statistical use and the like data science behind everything, are usually projects, especially in the challenge one, done for like distribution of existing data, or like can they also be used towards like prediction? I was also investigating a little bit and found that like people used RStudio like for example to predict the results in Pakistan elections a few years back to a very good degree of certainty. Is this also something that DAMS like goes for, or is it more about like distribution kind of thing.
Yeah, the club is moving in the direction of like data science, like statistics, prediction, that sort of stuff. Unfortunately, we don't go over that part of data science in this class. We do go over like data visualization and more of the distribution. So like honestly, looking for causation in C1s, unless you like want to go over the workshop that we mentioned on regression, unless you're looking for causation, it's probably going to be more advanced. Or like if you know the statistics, great. But we're looking more for like correlation at this level. But if you want to go for it, and if you want to like put in the extra time, like we're more than happy to help you go through it. Okay, cool. If you have any further questions, just pop in the chat and I'll be more than happy to answer. Great, this is our first demo. This is RStudio. If you haven't been able to download R in RStudio, you can stay behind when we put you into breakout rooms and we can help figure that out with you. So this is where we're gonna be doing all of our coding. Let me just like quickly introduce you guys to how RStudio works. So on the left half of my screen right here, you see like this is where all of my code goes. I have some parts that in my laptop appears with a black background, and I have some parts that appear with like a more grayish background. This part with a black background is like where all like my notes go or my comments go, or like I ask questions, where I like write stories or write instructions. This part here in gray is called a chunk. And that is basically like where you run all your code and like write all your code and stuff. If you want to like create a new chunk, you can just like make space within the black part. And then if you move your mouse up here to the top, you're going to see this. You're going to see a green button with a C. If you click on it and press R, that's going to insert a new chunk. So green button plus R. Alternatively, if you want the shortcut, you do Option Command I or Alt Control I in Windows. That makes a new chunk easily for you guys. So that is how chunks work. Anything that goes inside these, like, I guess like tildes is what you call them. I'm probably wrong about this, but inside these apostrophes is code that the program is going to interpret as being our code. Anything that is outside is going to be like your comments or that sort of stuff. Any questions about how this part of RStudio works? Okay, sounds good. So that's for this part. Then at the top right of here, we have the environment. The environment is like where we save all of our variables, like where you have like all the information about what variable means what. So for example, here, let me just go back to this chunk right here, where it says A_3. What this is doing, it is creating a new variable called A, and then it is assigning it the value 3. So if I just like put my mouse on this and click the play button, see, if I go to the global environment, I have a variable called A, which is assigned the value 3. If I want to check that A is actually 3 and not something else, I can just like run this, press the green button, and it's going to print me out 3 right here. Also, I have this thing down here called the console. If you can't see the entire thing, you can just like click this to maximize it a bit and just drag. Yeah, you see here that like everything I do, all of my output goes into the console, just as here, for example. Note that if I don't create a variable and assign it something, like if I just print B, that's not going to work. It tells me that there's an error, object B not found, because I have not assigned it a value. But for example, if I want to assign it one, assignment operator is option minus or alt minus or plus, one of the two for Windows. If I go to option minus, I get the arrow. Let's assign it the value high. And then if I just like print B, I'm going to get high. Okay. One clarification, this variable is of type we call integer because it has a number, like a full number that is rounded. This variable is called a string. Basically, a string is just like a string of characters that we put together, and strings always go in quotes. Okay, sounds good. And as you can see, B here is saved to the environment, which is like just makes it easy to track what value stands for what thing. Great. Any questions about anything up to now? Cool. Also note that you're going to have to like run all these chunks every time you open the file. That is a bit of a nuisance, but like the memory of RStudio is gonna get erased most likely. So like if I just come into this file and I run A to like print this value, it's not gonna accept it. It's not gonna know what A is. So make sure to like run this first and then run this later after you like declare the variable. Okay, that's it for like this part, and this part down here. We're missing this part at the bottom left, which is the help menu. Before that though, let me just make a new chunk and read in library tidyverse. We had a step in the beginner guide about installing tidyverse. Basically, tidyverse is the package that we swear by in R. It's as its name says, super tidy, super easy to read, super easy to understand. And that's where like most of the new things get added into R, and it helps us like do graphs, do plots, do maps, etc. And every single time that I open a new file in R, I'm gonna have to do this chunk, read in library tidyverse, and run it. Otherwise, R will not know how to import the new functionality I'm using with this. Note that I have to install tidyverse only once, but I have to run library tidyverse every single file that I open, just so that RStudio knows what I have to do. Okay, so moving on. The package tidyverse comes with a built-in data set that is called diamonds. Let me just run this chunk and look down here at the help menu to see what happens. If I run this, I'm gonna get search results. So this is a help menu where I can like basically look up anything, any function, any data set that comes with R. And it's gonna give me like a description of what it's used for, like how to use it, etc. So here I have two results. So this is a data set. I would intuitively go for the thing that says data, click on that. And it tells me that it's an artificial data set, a data frame. It's like a table with 440 rows and 10 columns. So the column names are like index, caret, color, clarity, etc. And that's like gives me a description of what each column stands for. So that is a help menu, tells you like what comes with a data frame or like with a table, and how to use it. Any questions about this? Okay, sounds good. Reminder, if you want to open up the help menu, just type whatever you want to look up and then type in front of it, question mark, run this, and it's going to appear down here. And then if we want to print this data set to the console, we just like write its name, run this, and it's going to print. This is showing us all the variables as columns here. If there were more than 10, like you'd probably see an arrow to the right up here that like allows you to like scroll to the right. And yeah, this is only showing like the top 10 of like 54,000 rows. If you want to like move to other rows, you can just like move to 6, 7, 8, etc. Great. So that is our diamonds data set. Let me just move on to a new thing. We're going to go over our first function, and I promise it's going to be the end of the first demo. I know it's a ton of information to shoot at you for the first time. Our first function is called mutate. Let me just open the help menu to see what mutate does. So mutate creates, modifies, and deletes columns from tables. If I have a new variable that I want to add, it's going to add a new column. If I have an existing variable, it's just going to override that column. And if I go down to usage, it tells me like how I can invoke this function. Let me just make a pause before that. And for those who don't have a background in CS, explain what a function is. A function is basically like set of steps that take an input and convert it to an output. So I'm going to steal Wes's analogy here. Imagine that you have a computer and the input to the computer is like pressing the on button. Then the function that turns the computer on is going to like bust it up. And then the output is going to be like your screen turning on, for example. So the function just takes the input, which is like turning it on, and then it's going to do some steps to convert it to an output. Any questions about like what functions are, how they work, that sort of stuff? Okay, good. Functions, as you can see here, they always take parentheses. Whenever you write the name of a function, you have to write parentheses. Otherwise, RStudio is not going to recognize the function as such. And if you look down here, all the things, like all the rows that are here inside the parentheses are called arguments. Arguments are basically the inputs that we give to the function. So for example, my first input is .data, which if I scroll down to the description of .data, it says a table, basically. Then I have ... which unfortunately it doesn't tell me what it is, but if I go down here, it's going to tell me pairs of names and values. Let me just scroll into that for a second. Imagine that I have this diamonds data frame, okay? I assign the diamonds thing to a variable called data frame df. And let me actually make this a bit clearer. So imagine that I have the price of diamonds and this is in dollars, and I want to get the price in soles, Peruvian soles. So for example, I would first set a variable, Peruvian soles, conversion, set it to, I think it's like $3.7 or something. And then I want to create a new column that has a price in soles. So what I would do is I would call mutate, put my parentheses, make a new line. First argument, always the data. So I'm gonna write .data, as it tells me, equals, and it's gonna be the name of the data frame. In this case, the name of the data frame or the table is diamonds. So that's it for my first argument. I already did this, so that's clear. Next, what mutate does is, remember we said that mutate adds new columns or like transforms existing columns. In this case, I want to add a new column called price in soles. So I'm gonna type the name price in soles, and I'm gonna give it a value. Then the value of price in soles is gonna be price multiplied by 3.7. The asterisk doesn't multiply, by the way. Okay, so if I just run this, you're gonna see the output. Remember that here, like this part of the table looks exactly the same as this part, only that I have a new variable at the right called price in soles. What it basically did is it took the price of each row and multiplied it by like 3.7 to give me a different price. For example, 1200 is different from like 1243 for each row. So this is like going through like each row and making a transformation of each row based on what I told it right here. So this is the part of the mutate function that is called ... name value pairs. The name of the new column goes on the left, the value goes on the right of the equal sign. Okay, and the rest you don't have to worry
about. Is there
about.
something else you can do to make it show up in the column right after price if you wanted to? So it doesn't get put at the end, it gets put right next to price.
Yeah, it always gets put at the end, but I can use a different function that we can look into in another. I can actually do it now, but I just don't want to confuse people.
Sure.
The function called select. Select just like chooses some columns for me. So if I want to just like have this table say price and price in soles, do price and price in soles, and then I just like get those two. But yeah, forget about this. We're gonna look at it later on. But yeah, any further questions about mutate? Okay, sounds good. Let me just introduce another new concept in R called the pipe. The symbol for the pipe is, let me just write it here and copy it. This is Shift Command M in Mac, Shift Control M in Windows. So that is the pipe. Basically, the pipe takes what is to the left and puts it as the first argument of the function to the right. Okay? In this case, if we have mutate, the first argument is data, right? So if we pipe something into mutate, then the function would interpret whatever is to the left of this pipe as the data, right? So example, let me just comment this out. Okay, there we go. If I wanna do the exact same thing as this, I'm gonna write the name of the data frame, which is diamonds, to the left, pipe this into a mutate function. And instead of writing .data equals diamonds, I can just delete that because it's no longer necessary. It will take .data to be diamonds. I can just write price in soles equals price times the conversion. Oh, I forgot to do that. For price, it was previous soles conversion. There we go. And if I run this, I'm gonna get the exact same result. See, compare this column to this column up here. It's the exact same thing. The only difference is that I'm using better style and like by using the pipe shorthand. And again, it's whatever is to the left of the pipe, in this case diamond, is gonna become the first argument, which is as you can see here, data. I know this is kind of tricky. It took me a while to understand, but please ask any questions about this if there's any.
Does that mean the first argument, like in the prior chunk that you did, or is this kind of a standalone?
Yeah, each chunk is standalone. Like for example, if I print diamonds again, you're not going to see the price in soles column because I didn't save it to the data frame. But if I save it, as I'm going to do now, this is saved, right? And if I print diamonds, now it's going to have the price in soles. But just because I didn't save it, it's going to be like independent.
Okay.
If I did save it, like it would affect the entire flow. Great. Any other questions?
So like if it's independent, well, how often do you have to do the dot data equals diamonds?
Depends on how many transformations you want to do. So for example, if I wanted to, imagine that the price in soles, imagine that we have another currency. Let's say price in pesos and the conversion rate is like, I don't know, like 20. And imagine that I want to do another column that has price in pesos as well as price in soles. And I don't want to do like dot data again. So I would just pipe this. Remember that the pipe takes whatever is to the left of it. In this case, whatever is to the left is this entire thing. Pipe that into another mutate function. Create a new column called price in pesos. And set it to price equals price times the price pesos conversion rate. Run that. Print that. And we have both price in soles and price in pesos. So if I want to do like multiple operations, you could just like use multiple pipes. And remember, each pipe is going to take whatever is to the left of it before this like arrow sign. Is that kind of clear?
One question. For the pipe, it's just Shift Command M, or the percentage thing before too?
No, just Shift Command M.
Okay.
I will be sending a cheat sheet through the Slack after this with like all the shorthand things, all the shortcuts to make your life easier. Great, yeah, that's about it for the first demo. We did have an activity that was supposed to be done in the breakout rooms, but let me just like move fast with this together so that we can actually get to the second part, which is more interesting. We can just answer this as a group. Okay, this is the activity. Question run library tidyverse. I'm not gonna see any result because I ran this before in this session. Remember that when I first ran it, I had this output when I ran library tidyverse right here in the console. This was my entire output. So it shows me all the packages. Let me just choose a couple of packages within tidyverse that I think are the most useful. ggplot is for making graphs. Anything that says ggplot is making graphs. Table is anything that manipulates tables or data frames. And stringr is used to manipulate strings. And then dplyr is again to manipulate data in general. You just don't need to know this information. There's honestly like just practice to see like what packages turn out. But honestly, if you were more interested, you could just like type in ggplot into the search bar or like ggplot package. And it will tell you what it is, give you links to like further information on like how to use the package, like what functionality it has, etc. So that's something useful to do. Great, I'm gonna take answers for this one. What are the main differences between install packages and library, and how often do you need to take each one? Any ideas?
The install packages you only had to do once, and then library you had to do every time.
Perfect. Yeah, that's exactly what Amy said too. So yeah, perfect. Also, one last difference. When you do install packages, you always do double quotes. So like, for example, if I wanted to install a package called SF, which is like to draw shapes, I would have to like put it in quotes too first. And then when I do library SF, it's without quotes. So yeah, perfect. Install packages only once and then library for each single file. So if I open, like this is a new file, I would have to run library tidyverse too. Great, that is our entire activity 1. Let me just stop the recording there because I already have the one from yesterday for number 2 and put everybody into breakout rooms.